In the previous lectures, we talked about methods for analyzing compound statements, statements that are made up of logical connectives like and or. Now, those tools go a long way toward analyzing the ways that we reason about things, but they do have their limits. For example, I've got a fairly simple argument here, but the tools we've discussed so far don't help us with this kind of universal statements like all firemen. To do that, we're going to have to introduce a new concept called a predicate and develop new methods for analyzing them called predicate calculus. So a predicate is the next step towards the kind of variable statements we're used to seeing in math classes. Statements that make general statements about groups of objects like all even numbers are divisible by 2, or there exists a rational number between every pair of real numbers. So what we mean by a predicate is a sentence that has one or more variables in it. Right, now notice that I didn't call it a statement. Remember that a statement is a sentence that is unambiguously true or false. We don't get that when there are variables involved. For example, the sentence x plus y equals 0 could be either true or false, depending on the specific values of the variables. It's that uncertainty that reduces it to just a sentence. It's only when you substitute specific values for the variables that it becomes a statement. So just like in your algebra classes, the set of all values that could be substituted for the variables are going to be called the predicates domain. So you can see here the language that we'll use to talk about predicates. Right? It should always come with two parts, a domain and some kind of sentence or sentences that describe the relationships between the variables or that says something about their properties. And finally, to name a predicate, we're going to borrow the same notation that we use to define or to name functions. Okay, now notice how, unlike in your algebra classes, the domain isn't concerned with whether or not its values make the statement true or not. In this case, for example, x equals 0.5 is in the domain. It's a positive real number. However, it doesn't bother me that if I put 0.5 in here for x, this becomes this statement. And notice I called it a statement now, right? Because once we put a number in there, I can make a definitive statement about whether this is true or false. Right now, if I simplify this, I get 1.5 is greater than 2, and that is a false statement. Right now, on the other hand, right, if you solve this inequality like you would in an algebra class, subtracting 1 from both sides, you end up with the inequality x is greater than 1. Or you end up with a subset of the domain. Now, these are all the values from the domain that make the statement true. We have a name for this subset. It's called the truth set of the predicate. All right, so the next step in our study of predicate calculus will be to look at two specific types of predicates, universal ones and existential ones. And these will be another step toward working with the kinds of statements that are actually used to talk about mathematical objects.